The original designers did not envision the Internet growing as large as it has. At the time, a 32-bit address seemed so large that they quickly divided it into different classes of networks to facilitate routing rather than reserving more bits to manage the growth in network addresses. Whoever thought we would need a PC with more than 64 kilobytes of memory? To solve this problem and to create a large number of new network addresses, another way of dividing the 32-bit address was developed, called subnetting. An IP subnet modifies the IP address by using host address bits as additional network address bits. In other words, the dividing line between the network and the host address is moved to the right, thus creating additional networks, but reducing the number of hosts that can belong to each network. When IP networks are subnetted, they can be routed independently, which allows a much better use of address space and available bandwidth. To subnet an IP network, you define a bit mask known as a subnet mask, in which a pattern cancels out unwanted bits so that only the bits of interest remain. Working out subnet masks is one of the most complex tasks in network administration and is not for the faint of heart. If your network consists of a single segment, in other words, there are no routers on your network, you will have you will not have to use this type of subnetting. But if you have two or more segments or subnets, you will have to make some sort of provision for distributing IP addresses appropriately. Using a subnet mask is the way to do just that. The subnet mask is similar in structure to an IP address in that it has four parts or octets, but it now defines three elements: network, subnet, host, rather than two: network and host. It works a bit like a template that, when superimposed on top of the IP address, indicates which bits in the IP address identify the network and which bits identify the host. If a bit is on, such as 1 in the mask, the equivalent bit in the address is interpreted as a network bit. If a bit is off, such as 0 in the mask, the bit is part of the host address. The 32-bit value is then converted to dotted decimal notation. In general, you will only use one subnet mask on your network. A subnet is only known and understood locally. To the rest of the Internet, the address is still interpreted as a standard IP address. Okay, default subnet masks for standard IP address classes. Class subnet mask bit pattern subnet mask class A 1111111 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. Subnet mask 255.0.0.0. Class B 1111111 dot 1111111 dot 0 0 0 0 0 0 0 dot 0 0 0 0 0 0 0 255.255.0.0. Class C 1111111 1 1 1 1 1 dot 1 1 1 1 1 1 1 1 dot 1 1 1 1 1 1 1 1 dot 0 0 0 0 0 0 0 0 255.255.255.0. Routers then use the subnet mask to extract the network portion of the address so they can send the data packets along the proper route on the network. Because all Class A and Class B networks are taken, who are most likely to encounter subnet related issues when working with a Class C network. Subnetting a Class C network. How do you find out the values that you can use for a Class C network subnet mask? Remember from a previous discussion that inter-network interface card defines the leftmost 3 octets in the address, leaving you with the rightmost octet for your own network addresses. If your network consists of a single segment, you have the following subnet mask. 1 1 1 1 1 1 1 1 dot 1 1 1 1 1 1 1 1 dot 1 1 1 1 1 1 1 1 dot 0 0 0 0 0 0 0 0 0. When expressed as a decimal number, this is 255.255.255.0. Because all of your addresses must match the leftmost 24 bits, you can do what you'd like with the last 8 bits, given a couple of exceptions that we'll look at in a moment. You might decide to divide your network into 2 equally sized segments with, for example, numbers 1 through 127 as the first subnet. So 0, 0, 0, 0, 0, 0, 0, 1 through 1, sorry, through 0, 1, 1, 1, 1, 1, 1, 1 in binary. And now the numbers 1 through 8 through 255 as the second subnet. 1, 0, 0, 0, 0, 0, 0, 0 through 1, 1, 1, 1, 1, 1, 1, 1 in binary. Now the number inside the subnets can only vary only in the last 7 places, and the subnet mask becomes 255.255.255.128. In this in binary, this is 1 1 1 1 1 1 1 1 1 dot 1 1 1 1 1 1 1 1 dot 1 1 1 1 1 1 1 1 dot 1 0 0 0 0 0 0 0. Now let's get back to the exceptions mentioned earlier. The new network is the first number in each range. So the first subnet's network number is x dot y dot z dot 0, and the second is x dot y dot z dot 128. X, Y, and Z are the octets assigned by the inter-NIC. The default router address is the second number in each range x dot y dot z dot 1 and x dot y dot z dot 129, and the broadcast address is the last address for x dot y dot z dot 127 and x dot y dot z dot 255. You can use all of the other addresses within the range as you see fit on your network. The following table describes how you can divide a Class C network into 4 equally sized subnets with a subnet mask of 255.255.255.192. This gives you 61 IP addresses on each subnet once you have accounted for the network, router, and broadcast default addresses. So Class C network divided into 4 subnets: network number, first address, broadcast address, x dot y dot z dot 0, x dot y dot z dot 1, x dot y dot z dot 63, x dot y dot z dot 64, x dot y dot z dot 65, x dot y dot z 127, x dot y dot z 128, x dot y dot z dot 129, x dot y dot z 191, x dot y dot z 192, x dot y dot z 193, x dot y dot z dot 255. Class C network divided into 8 subnets. Network number, first address, broadcast address, x dot y dot z dot 0, x dot y dot z dot 1, x dot y dot z 31, x dot y dot z 32, x dot y dot z 33, x dot y dot z 63, x dot y dot z 64, x dot y dot z 65, x dot y dot z dot 95, x dot y dot z 96, x dot y dot z 97, x dot y dot z 127, x dot y dot z 128, x dot y dot z 129, x dot y dot z 159, x dot y dot z 160, x dot y dot z 161, x dot y dot z 191, x dot y dot z 192, x dot y dot z 193, x dot y dot z 223, x dot y dot z 224, x dot y dot z 255, x dot y dot z 255. So I'm going to leave it here today for this video. So if you liked listening, please consider like, sharing, and subscribing. And thank you again.